Alright, so up next, we want to find the actual magnitude of the unknown capacitor from the given info, and we're going to do it with a graph. Alright, so we established in the last video and in the last two questions that these capacitors are most likely in series with one another. So because of that, we know that I can draw that same diagram I had. Here they are. They do not have the same voltage across each of them. So when I write the capacitance of the unknown one is equal to Q over V, V unknown, we'll call that. And the capacitance of the known one is equal to Q over the V of the known capacitance. These Qs are actually the same because they have the same current flowing throughout the circuit. So let's solve for each Q and set them equal to one another. That means C unknown times the voltage of the unknown is equal to the C of the known times the voltage of the known one. And C unknown is therefore the known capacitor times the voltage of the known capacitor over VU. And this is a very good equation to use because it's very simple. There's not much going on. It doesn't have any powers of 2. There's nothing we have to do to linearize the scales here. So I can plot this. This would give me the slope of a plot, and I want that to be my delta y over my delta x. So on the horizontal axis, that'll be my delta x, I would plot VU. And on the vertical axis, I would plot the capacitance of the known capacitor times the voltage of the known capacitor. And I can actually go ahead and do this. I've done it ahead of time, so I can save some time in the video. On my calculator here, we go to Stat, Edit. I've done that right here. In the x-axis, I've put the voltage of the unknown capacitor, and in the y-axis, I've done the product of the known capacitance and the voltage of the known capacitance. And then the answer is going to be given to me in microfarads. So I can go to Stat, Calculate a linear regression line. And obviously on the exam, you had to use this. I'm just using this to save some time. And calculate, and the slope of that line comes out to around 51.9. So I would say that, I believe the next question is, what is the actual, using your best fit line, determine the capacitance of the capacitor. So we can't really do any error propagation here, but it would be around 51.9011 microfarads. That would be the best educated guess. And obviously there's, some like unknown like tolerance value you can figure out, but we don't have to worry about that right now. So yeah, that would be your answer for this next part, around 52 microfarads. Moving on to part 3. Let me see if I may run out of time. Yeah, I'm going to cut this one short. See you in the next video.